Good morning. Welcome back to next lecture. In the last lecture, we have discussed the method of completing squares for solving a quadratic equation. And this method actually involved transforming a quadratic equation into a perfect square trinomial and which can then easily solve it. So here we want to find out the minimum or maximum value of a quadratic function by using completing squares, which is considered as one of the application of the completing squares. See, as we discussed in the previous lectures that the quadratic equation is a polynomial equation in which the highest power of the unknown is 2. The general or standard form of the quadratic equation we know it is f of x is equal to it is ax square plus bx plus c is equal to 0. Or here a, b, c are the constant and a is not equal to 0. So completing squares see is an algebraic technique which we are already discussed earlier, which is used to write the quadratic equation in the form of squared brackets or a complete square form. This method is useful when factoring is not immediately possible, or this method is suitable when we are dealing with the quadratic function not easily factored, or when we want to find out the vertex of the quadratic function. So here this is we are giving more emphasis, that is how to find the vertex of a quadratic function, that is minimum or maximum value of a quadratic function. See, one of the important application of the completing squares is to find maximum or minimum value of a quadratic function. And the graph of this function in the last lecture also we drawn, it is generally the shape of a parabola. And the orientation of the parabola either upward or downward is entirely depending upon the sign of coefficient of x square, that is the sign of a. And it extends upward if a is greater than 0, then the vertex determine the minimum of the function, and that is where the parabola will be open upward so that we have a minimum point of the function. Similarly, the graph extends downward if the coefficient is a is less than 0. So at that particular point we have a maximum point of a quadratic function. So here we want to find out the minimum or maximum value of a quadratic function. Now we will find some derivation. See, we are going to derive the maximum and minimum value from the general quadratic term. Let us take the general format of the quadratic function. See, it will be ax square plus bx plus c is equal to 0. We are equating with 0. Then after that, we are going to restructure this particular general form. How we are going to restructure here? See here, the first term we are putting as it is plus, that is ax square we are putting as it is plus. Then we are going to multiply and divide with 2a. See, we are multiplying and dividing with 2a, that is 2a divided by 2a into the second term, that is bx. So here we are multiplying and dividing 2a with the second linear term, that is bx. Is nothing going to happen when you are going to multiply and dividing a term with the same number. So here 2a is common, so there is no problem regarding the value, it will not change. So here after that plus we are adding a new term here, that is it is a into b by 2a whole square. We are adding a new term which is not here. So here we are putting here a into b by 2a whole square and subtracting the same term here. See, minus a into b by 2a whole square. So adding and subtracting. So the value will be remain the same. Then what is remaining here? It is constant, that is c. We are putting plus c here. So our equation will be c ax square plus 2a divided by 2a bx plus a into the b divided by 2a whole square minus a into b divided by 2a whole square plus c. See, then the same step we are following here, but we are just going to rewriting here the 2a term. we are taking the 2a into the numerator, 2a into the left side. So here, see here, it is 2a we are putting out of the bracket, and putting the b term we are putting in the bracket. So it will become, see, b by 2a. The denominator is same, 2a. The numerator 2a is taken here outside. Then what is remaining? The x term, variable x is remaining here. So we are putting it is ax square plus 2a b by 2a x. So we are just rearranged. We are just rearranged the term. Then what is remaining here? It is plus a into b by 2a whole square minus a into b by 2a whole square plus c. Now see here, we have a is the common term. Here ax square, 2a, and here also a. So a is the common term. So I am going to take the a into the outside the bracket. Then it will become only for this particular terms. See here, taking a outside, what is remaining here? It is x square plus a is taken outside. So it is 2 into b by 2a into x plus again this a is taken outside. So what is remaining? It is b by 2a whole square. I am putting in a square bracket here. Minus, see, is a into, I am going to remove this particular square. So it will become b square divided by 2 square a square. That is 2 square will become 4. Then a square plus c. So this term will become b square divided by 4 into a square plus c. Now see here, we are again going to simplify it by taking the first term as it is. This term we are putting as it is here. Then this particular a and this a square term will be cancelled out. So a into a square term will be cancelled out. What is remaining? It is b square divided by 4a. b square divided by 4a. The square will be cancelled out with this particular a and plus c. Now look at here. We have this particular term. We know this is a complete square term. This is a complete, first term is complete square term. It is just like, it is a plus b whole square. We know a plus b whole square is equal to a square plus 2ab plus b square. So here we are assuming that a is equal to x. In this particular equation, we are assuming that a is equal to x, b is equal to b by 2a. Then here, see a square, that is x square, plus 2 into ab, that is b is here, b by 2a into a, which is x, then b square, that is b by 2a whole square. So it is completely equivalent to the a plus b whole square. So I can write this particular term, that is a into x plus b by 2a whole square. This is a complete square term. A into x plus b by 2a whole square. We are simplified in this particular factor. Now see what is remaining. Here we have a constant term, that is minus b square divided by 4a plus a. Here we will find a common denominator so that we can simplify it. See here we have a common denominator and combine the term. The common denominator here it is 4a. So I am taking the 4a, multiplying and dividing with the 4a with the constant c. Then it will become b square divided by 4a plus 4 into a into c, that is 4ac divided by 4a. We have a common denominator now, 4a I am taking common, taking minus outside. So it will become b square minus 4ac. So this term will become b square minus 4ac divided by 4a. So I am combining this term along with this particular term, that is a plus b whole square term, complete square term. So our equation will become, this particular equation will become a into x plus b by 2a whole square minus the constant term will become minus b square minus 4ac divided by 4a. See, thus we have a complete square transform, a appearance of a quadratic function without changing its values. So here this is a full square term, x plus b by 2a whole square. Then we have b square minus 4ac divided by 4a, which is constant term. This is new constant term. Now see, this is our terms we are derived here. For the quadratic function, when a is greater than 0, we said that parabola open upward and the vertex represent the minimum value of the function. See here, if you solve x, this particular solve for x, then x is equal to minus b by 2a. If you solve for x, then it is minus b by 2a. It is the x coordinate of the vertex. And we can say that when x is varying here, if x is varying, then only the value of this particular term, that is complete square term, will vary, but there is no changes will be happen to the b square minus 4ac divided by 4a. So at vertex x is equal to minus b by 2a, then this particular expression will become 0. If you are assuming x is equal to minus b by 2a, then this term will become 0, and minimum value of the function then equal to minus b square minus 4ac divided by 4a. So if the leading coefficient a is negative, then it indicates that the parabola opened upward, and if leading coefficient, that is a, is less than 0, then the function represents the parabola that opened downward, and the vertex of this particular parabola will be the maximum point. So thus we can say that if a is equal to greater than 0, then f of x ax square plus bx plus c has minimum at x is equal to minus b by 2a, where and the value will be c minus b square divided by 4a. So here the vertex represent the minimum point of the parabola. So minimum value occur at x is equal to minus b divided by 2a, and the value of function at this particular point will be c minus b square divided by 4a. Similarly, what happens if a is less than 0? See, if a is less than 0, then the quadratic function open downward. This ax square plus bx plus c, where a is less than 0, then we have a maximum point because our quadratic function open downward. So we will have a maximum vertex point. So its vertex represent the maximum point on the parabola, and the maximum value will be occur when x is equal to minus b by 2a. And what is the vertex at the maximum point? It will be c minus b square divided by 4a. We will solve it considering some of the example. See, we can find the maximum or minimum value of a given function, that is f of x is equal to x square minus 4x plus 3. See, in order to find out the maximum or minimum value of a quadratic function, we can use either by using the equation which we are already derived earlier, and that is complete term and with the constant term which we are already derived here, or you can use the method of completing squares which we are already explained in the last lecture. So that can also be utilized for finding the solution of a quadratic equation. See, we are going to explain here the both methods. First, we are using the method which we are already derived here. So here, the function f of x is equal to x square minus 4x plus 3. Here a is equal to 1, b is equal to minus 4, c is equal to 3. Then our equation is here, that is the complete term, and we have a constant term, that is a into x plus b by 2a whole square minus b square minus 4ac divided by 4a. And we know the values of a, b, c. We are simply going to substitute all these values here. Then it will become, see, a, it is 1, x, we are going to find out, x minus b by 2a, that is 4 divided by 2 whole square, minus 4 square minus 4 into 1 into 3 divided by 4a. So if you go for simplifying it, then it will become, see, this is the complete term, we can write it is x minus 2 whole square. This can be termed as, it is x minus 4 by 2, it is 2, so it is x minus 2 whole square multiplying with 1, so it will become x minus 2 whole square minus 4 square, which is equal to 16, minus 4 into 1 into 3, which is equal to 12, divided by 4 into 1, which is equal to 4. So here we can simplify again, x minus 2 whole square minus 16 minus 12, which is equal to 4, divided by 4, which is equal to 1. So we have minus sign here, so it will be minus 1. So we have a x minus 2 whole square minus 1. See, to find out the maxima or minima value of a quadratic function in a complete square form, we can analyze the coefficient of the squared term. See, what is the coefficient of the squared term here? Here it is 1. The coefficient of the square term is equal to 1. That means here a is greater than 0. So in this case, the parabola open upward and the function will have a minimum value which occur the vertex, which is the point, that is vertex point, which will be minimum value. So therefore here the given quadratic equation is minimum as the coefficient is greater than 0. So the vertex of the parabola is given by the coordinate derived from the given solution of the complete square term, that is x minus 2 whole square. So in this case, vertex or the line of symmetry that will happen, that is x is equal to 2. We are solving here within the bracket term, that is x minus 2, so it will become x is equal to 2. So in this case, the line of symmetry is equal to x is equal to 2, and the minimum value of the quadratic function here, that is y is equal to minus 1. So which occur, that means the minimum value occur when x is equal to 2. So here the vertex of parabola occur, that is minimum reaches at x is equal to 2, that is the function reaches to the minimum value when x is equal to 2, and what is the minimum value, which is minus 1. So in this way we can find out. Or you can use the another method, that is method of completing squares, which we are already discussed earlier. See, we can find out here by using the same example. See, x square minus 4x plus 3. So here first step, by using the method of completing squares, you might have been remember, that is first step we have to set the equation equal to 0. So it will become x square minus 4x plus 3 is equal to 0. Then the next step, we subtract the constant term from the both side. So it will become minus 3 here. So it will be x square minus 4x plus 3, minus 3 will be cancelled out, and the right hand side of the side it will be minus 3. Then after that, we have the coefficient is 1, x square coefficient is 1, so there is no need to divide the entire term. We have need only 1, especially as a coefficient of x square. So now we can simplify here by adding the term b by 2 whole square. We are going a middle term, that is b by 2 whole square, and adding in the both side of the equation b. So here what is the b, which is equal to 4. So I am substituting here x square minus 4x plus b, that is 4 by 2 whole square, which is equal to minus 3 plus 4 by 2 whole square. So here we can simplify again x square minus 4x plus 4 divided by 2, which is 2, 2 square, which is equal to 4. So 4 by 2 whole square will become 4, minus 3 again 4 by 2 whole square will become 4. Now we have a complete square term here. Here we have a complete square term. So we can write this is x square minus 4x plus 4, which is just like it is a minus b whole square. We can write it is x minus 2 whole square. It is the expansion of the x minus 2 whole square, and minus 3 plus 4, which is equal to plus 1, taking into the left side of the equation, so it will become minus 1. So our equation will become x minus 2 square minus 1. So which we are already estimated in the earlier examples as well. So here the minimum, the function is reaches to the minimum when x is equal to 2 and the minimum value is equal to minus 1. Similarly, we have to consider the another example, x square plus 4x minus 5. By using the completing squares, we are equating with the 0 the term, then we are going to subtract the constant term from the both side of the equation, so it will goes to the right side of the equation. This equation will become x square plus 4x is equal to 5. Then we are adding b by 2 whole square term in the both side of the equation. It will become 4 by 2. Again here it is b is equal to 4. So it is 4 by 2 whole square, which is equal to 5 plus 4 by 2 whole square. If you go for simplifying it, then it will become x square plus 4x plus 4, which is equal to 5 plus 4. And this is the complete square term. So we can say that it is x square plus 4x plus 4, which is equal to 5 plus 4, which is equal to 9. And this can be right, it is x plus 2 whole square, taking 9 into the left side of the equation, so it will become minus 9, which is equal to 0. So here the function will reach to the minimum. See, when x is equal to, because coefficient is equal to 1, that is a is greater than 0, so the function is minimum, and the function is reaches to the minimum when x is equal to minus 2. And what is the value of minimum value, which is minus 9. The minimum value is equal to minus 9, that is constant term. Now consider another example. that is f of x is equal to minus 2x square plus 40x minus 600. Here the coefficient of x square is equal to minus 2. So by looking at this particular coefficient, you can determine what actually the shape of the parabola. See here, a is equal to minus 2, b is equal to minus 40, c is equal to minus 600. We are going to use the earlier equation which we are already derived, that is a into x plus b by 2 a whole square, b square minus 4ac divided by 4a. Here all the values are given here, just we are going to substitute a, b, c here in the equation, then it will become a is equal to minus 2, x minus 40, see b that is 40 divided by 4 whole square minus 40 square minus 4 into minus 2 into minus 600 divided by 4 into minus 2. If you go for simplifying it, it is minus 2 x minus 40 divided by 4 which is equal to 10. So it is x minus 10 whole square minus 40 square which is 1600 minus 4 into minus 2 into minus 600 which is 4800 divided by 4 into minus 2 which is equal to minus 8. If you go for simplify it again, then it will become minus 2 into x minus 10 whole square which is equal to 1600 minus 4800 which is minus 3200. Then what is denominator? It is minus 8. So here again we are going to simplify, that is minus 2 into x minus 10 whole square. Then if you go for dividing minus 3200 divided by minus 8, you will get it is 400. But minus sign is here, so we are putting here also minus sign. So we have the final result, that is minus 2 into x minus 10 whole square minus 400. Now we want to find out the minima or maximum value of a given quadratic equation. Look at the coefficient of the complete square term. See, the coefficient of the complete square term is minus 2. So here minus 2, which is a, that is coefficient is less than 0, the parabola will be open downward, and therefore we have a maximum value occur at the vertex, which is the point that is maximum point on the vertex. Therefore here the given quadratic equation is maximum as the coefficient of the complete square term is minus 2, that is less than 0. So the vertex of the parabola is given the coordinate derived from the given solution of the complete square term here, that is x minus 10 whole square. So here we can say that, see, in this case vertex or the line of symmetry will be happen at x is equal to 10, because it is x minus 10. So it will be solved for x within the bracket term, then x is equal to 10. So the line of symmetry, that is at x is equal to 2, and the maximum value of the quadratic function, that is y is equal to minus 400. So which occur when x is equal to 10. So we can say that the vertex of the parabola is occur at x is equal to 10, that is the function is reaches x is equal to 10, and the maximum value will be here, it is minus 400. Now let us consider one more example, that is the function f of x is given, that is minus 3x square plus 30x minus 30. So here we are finding a is equal to the coefficient of x square which is minus 3, coefficient of x which is b which is 30, and the c term, that is constant term, is equal to minus 30. Now we are going to consider the equation, that is a into x plus b by 2a whole square minus b square minus 4ac divided by 4a. We know what is the value of a, b, c here. We are just going to substitute all these values in the given equation. So it will become a, that is minus 3 into x plus b, that is 30 divided by 2 into minus 3 minus b square, that is 30 square, minus 4 into 3 into, that is minus 3 into minus 30 whole divided by 4 into a which is minus 3. If you go for simplifying it, then it is minus 3 into x, then 30 divided by 2 into minus 3 which is minus 6, minus 30 square which is 900, minus 4 into 3 into minus 30 which is 360, divided by 4 into minus 3 which is equal to minus 12. Again we can go for simplify. See, minus 3 into x plus 30 divided by minus 6 which is minus 5. So we are writing here x minus 5 whole square minus then 900 minus 360, which is equal to 540 divided by minus 12. Again, we are going to simplify this bracket term, then it will become minus 3 into x minus 5 whole square plus 540 divided by minus 12, which is equal to plus 45. Why it is plus? Because minus also here, minus sign here also minus sign. So it will become plus 45. So now we can find the minimum or the maximum value of this given quadratic function, that is minus 3x square plus 30x minus 30, by looking at the coefficient of the complete square term. See, the complete square term is here x minus 5 whole square and the coefficient is here minus 3. So here the coefficient minus 3, which means a is less than 0, the parabola open downward and the maximum value occur the vertex, which is the point. And therefore, here the given quadratic equation is maximum as the coefficient of the complete square term is minus 3. The vertex of the parabola is given by the coordinates of derived from the given equation, that is x minus 5 whole square, this term. So in this case, the vertex or the line of symmetry will be happen by solving the within the bracket term, that is x minus 5 for x. Then it will become the line of symmetry, that is x is equal to 5 and the maximum value of the quadratic function, that is y is equal to plus 45. So which occur when x is equal to 5. So here the vertex of the parabola occur at x is equal to 5, that is the function reaches to the maximum when x is equal to 5 and the maximum value here it is 45. So in this way we can find the minima or the maximum value of a quadratic function by using the complete term with the constant term, which we are already derived earlier, or you can either use by using the method of completing squares. I hope it was clear to you. We will see in the next lecture. Thank you.